So the next functional group we're going to try to name is going to be the alcohol functional group. And so if we go through a couple of very common examples of alcohols, you'll see that all that's really happening is you're adding on an OH group. And so these are a couple of very common alcohols that you'll see over and over again, and they have common names to them. So this is methanol, and this molecule is ethanol. And this functional, or this overall group, is called isopropanol. And what you'll probably notice is that for the methanol and the ethanol, meth is going to correspond to this methyl group, and the eth is kind of corresponding with this 2-carbon ethyl group. And so the way that we're going to be naming these alcohols is we're going to try to include the number of carbons, but we're also going to end them in the very similar way, which is these OL endings. So every one of these has an OL ending. And then obviously isopropanol, this is the isopropyl group, so isopropanol. So let's try to name a very simple alkane in the formal way. So for this alcohol, the same thing is going to apply as with the alkyl halides or just regular alkanes, in that we're going to try to find our longest parent chain. And so the longest parent is going to be 1, 2, 3, 4, 5. So overall, this is going to be a pent numbering. So overall, this is going to be a pent numbering. So we could call this a pentane, except for the fact that we now have an OH or an alcohol. So what's going to happen is instead of calling this molecule a pentane, this ane, which indicates an alkyl group or a hydrocarbon, that's going to be replaced with this -al suffix. So instead of calling it a pentane, we just kind of take that E and subtract it and replace it with the OL. So this would be a pentanol parent. And so now the only thing we have to do now is to indicate where that OH group is actually located on the molecule. And so if we numbered 1, 2, 3, this would be 3-pentanol. So the 3 is indicating where that OH group is. Okay, so let's talk about this next example. It's a little bit less intuitive. So the first thing that you should notice is that you definitely have an OH group. And so overall, you're going to try to name this as an alcohol. And so again, the first step is always trying to find the longest parent chain. And so if we tried to find the longest, we could start up here, and that would mean 1, 2, 3, 4, 5, 6. So that would give us a 6 as a parent chain, versus if we started right here, 1, 2, 3, 4, 5. Now the issue comes with if we number from here and we only get 5, that's definitely a lower parent chain than if we start numbering from up here. But since this is going to be an alcohol, alcohols get a little bit more priority than just a regular alkane. And so we definitely want to always include the OH in the parent. So if you see an OH, it needs to be in the parent. So that must mean that we're going to number here 1, 2, 3, 4, 5. So again, even though we get a lower parent chain than if we start numbering here, we have to include the OH. So overall, the parent name for this molecule would be a pentanol. And if we now try to figure out the naming for the ethyl group, this is going to be on the 2 position. So this is going to be a 2-ethyl. And since the alcohol, the OH group, is located in the first position, we're just going to include that 1 just to make sure the audience knows where that OH is. So again, the 2-ethyl is saying that the ethyl group is on position 2, and that 1 numbering is saying that the alcohol is on position 1. Now this 1 might actually seem a little overzealous and a little bit of overkill, but let's give an example when it's actually very important to utilize this numbering. So in this example, all we've done is change this 1 position from having 2 hydrogens to having a methyl. And so now if we actually try to number here, we still need to utilize this OH in the parent. And so if we counted from here, it's only going to give us 1, 2, 3, 4, 5. If we counted from here, however, 1, 2, 3, 4, 5, and 6, this is going to maximize the number of carbons in our parent. So now, just by adding a methyl group here, we've changed this from a pent to a hex. And so now we have a hexanol, and now we definitely have to indicate where that hydroxy or OH group is. And now it's no longer in the first position, it's in the second position. So this would be a 2-hexanol. And now that ethyl group has just been switched from the 2 position to the 3 position. So this would still be a 3-ethyl.